All right, this is going to be 9.3, Geometric Sequences and Series, Part 1. And we're going to start by defining a geometric sequence. A sequence is geometric when the ratios of consecutive terms are the same. So if I have a sequence, A1, A2, A3, all the way to AN, it is geometric if AN divided by A1 is equal to A3 divided by A2, etc., etc., if all of those ratios are equal to R, and that's what we call the common ratio. Okay, so example number 1 says find the common ratio, and we have 2, 4, 8, 16 all the way to 2n, so we're basically going to divide 4 divided by 2, that gives you 2, and then the third term divided by the second term, that also gives you 2, and then just to do the other one, 16 divided by 8, that also gives you 2. So 2 is the common ratio. All right, the next one, we're going to go ahead and do the same thing. 36 divided by 12. I'm going to plug that into my calculator and just get a decimal. Or not, get an integer, 3. 108 divided by 36. That's also going to be 3. And then 324 divided by 108. That's also going to be 3. So my common ratio is 3. All right, so next we're going to find the formula for the nth term of a geometric sequence, which is going to be given by this formula right here. And we can write out the sequence as A1 is the first term. The second term is just A1 times R. The third term is A1 times another R squared. And then etc., etc., you just built your R's up. So it says write the first 5 terms of a geometric sequence whose first term is 3 and common ratio is 2. So that means R is 2 and then A1 is 3. All we're going to do is plug it into the formula. I'm going to copy down the formula first and then plug it in. And that's our formula here. We could simplify it if we want to, but that will be enough. All right, so next we're going to do example number 3. It says, find a formula for the nth term of a sequence of 5, 15, 45. So first thing we're going to do is we're going to find the common ratio and the first term. So my first term is 5, and then for the common ratio, what do I need to multiply 5 to get 15? 3. And then if I multiply 15 by 5, do I get 45? Yeah, by 3, yes. So then that works. The common ratio is 3. So we're going to find the general formula. So AN is equal to A1 R n minus 1. We're going to go ahead and plug in our first term, which is 5, and then 3 n minus 1. So this would be the general formula. Then let's find the 12th term, which is plugging in 12. Okay, and then you're going to use a calculator for this. So if you plug this into the calculator, you're going to get this number. All right, so example number 4 says the fourth term of a geometric sequence is 125. So a to the 4 is 125. Then the 10th term is 125 over 64. Find the 14th term. So we're going to go ahead and need to find what R is. So I'm going to do kind of like what I did for the geometric sequence, A4, A5, A6, A7, A8, A9, 10, and we know this is 125 over 64, and we know this is 125. Well, I need to multiply this by r to get the next one, then by r to get the next one, then by r to get 7, then by r to get the 8th term, then by r to get the 9th term, and finally by the last r to get the 10th term. So 1, 2, 3, 4, 5, 6. So I need to multiply 125 times 6 r's to get 125 over 64. Okay, so I'm going to solve for that r. Divide by 125 on both sides. Then you get r to the 6th is equal to 1 over 32. Okay, and then what value of r, when I raise it to the 6th value, it will give me 32, or 1 over 32. That's going to be 1/2. Alright, so now that we have 1/2, and then we have the 10th term, I went ahead and did the work, but you could basically multiply the 10th term by 1/2 to get the 11th term. Then whatever you get there, you would multiply it by 1/2 again to get the 12th term, multiply it by 1/2 to get the 13th term, multiply it by 1/2 to get the 14th term. In other words, you can multiply the 10th term by 1/2 to the 4th power, and finally you would get the 14th term, which is 125 over 1024, and that would be your answer.